Do you have the screen sharing?
Yes, the screen is shared.
On full screen. Okay, thank you. So another European project, but another context. Here we don't have fancy mathematics stuff. We don't have even big data, sadly. But we think we can have something that can be interesting in some context. I would like to expose or proposition how supply chain modeling can be used as a transversal tool to address several complex tasks. So normally the port activity scenario model. I will start by presenting the context because it will be the key point to understand the value of the proposition. Then I would explain our approach, why we do that and how we do it. And to give a little bit more concrete example, some use case, and we will finish with some perspective. So let's jump into it, the context. Oh, it seems you don't have. Okay, should be better, I guess. Okay, okay, sorry for that. So context. Here we are addressing the small ports. It means that they need a tool first to gather all the available data and found a way to extract value from it. Here we don't have a huge team of IT people and data science. I will not say they have nothing, but not enough. They have huge constraint because they have huge variability. First, about their data, you can have data come from a sponsor, from the port information systems. There's a huge difference for this kind of data. You have difference in the type of data. There is data that you can rely on. Some we don't know. Some other data we know that you cannot rely on it. Some are always available. Some will be available next week for the current week. Some ports or for some part of the terminal of the ports, they want something really precise, but sometimes they don't want something precise. They want something really simple. And if you want to provide a tool that can address a lot of different ports, you will have an issue because you will have different kind of goods, and managing container is pretty different than managing passenger or cargo, bulk cargo. And here we have to handle all of this, and the process are different. In some ports, they are the owner of every process and resource, and sometimes they own nothing. And finally, last but not the least, you have significant evolution of the process and machine. So you cannot so much exploit historical data to forecast future. So as you can see, it's not the sweetest spot for machine learning or uncertainty management. But anyway, we have to address this context. So we need to provide a tool that can adapt to the port context. So it means the tool should be able to handle data heterogeneity, multiple use for the user. They want to make assessment, monitoring, forecast, explore their process. And they can have type of use, focus on energy, on pollutant emission, efficiency in the process. And we have to scale our output precision to the input or the user needs. So there are some components of the Pixel platform. To put it briefly, you can picture that like a tree. So from the bottom to the top, you've got the roots that try to extract data from the environment, the trunk that manage the flux of the data in the whole system, the structure, and you've got the leaf. That's where we are here in the past model. We take the raw data and try to add a little bit of information on it, something more elaborate, until we can produce fruits that will be the end user takeaway. So now we've got the big picture. What is our approach with this supply chain modeling? If we try to explain really simply how does it work with a schematic linear view from the data on the left that come from sensor or any source, we will do a first step that is build the port activity scenario. Basically, from all this information that we have, we try to build a scenario that say what happened, when does it happen, and how does it happen. So it will be a three structure of the activity in the port. I will manage this boat on this dock with this machine, and after I will do that. That's what happened. And after, we will make calculation about the outcome. Okay, if this happened, what does it mean? What are the consequences? So now we will have a closer look on the port activity scenario builder. So here again, it's a really simplest view. I've got for example, with my vessel call, I've got the schedule of the boat. I have to unload this one, load this one with this content, this cargo. I've got information about what we call the supply chain that say an oriented graph of theoretical operation for this kind of content, for this cargo type on this dock. I will use a cron, and after that, when it is finished, it will trigger this operation that will occur for 20 minutes, and this one will occur until this other is finished, this kind of relation. And this involves machine, area, road that have a specification. This is the throughput of this machine, this kind of information. Will all this information and other, but we keep it shortly today, you obtain the path, the port activity scenario that you can see nearly as a Gantt. What happened, when, how. So it's quite simple, but there is interesting things in that to address our issue that is huge need for flexibility to adapt to the data and needs of the user. So here we've got flexibility. We can adapt the modelized parameters from the input. Are we considering a boat to load or unload, or trucks to load and unload, or both? Depending of the scope of your input, you will have the equivalent scope for your output. And depending of the input you provide, if you provide a live stream of data from sensor, you are actually monitoring what's occurring into the port. If you use historical consolidated data, you are actually doing assessment of what's happened really. And you can even elaborate some crazy scenario. What's happened if I change all my crane to electric stuff? Okay, let's explore that and compare scenario. If I do this modification, what is the difference on the result? You can do that. Another point is also a plasticity to adapt to what is available as data. If you have only a minimalist setup, you have only vessel call, so expected arrival and departure time. You describe all your process as one big step, a long step, without any detail. Even for the machine, you merge every machine and you say, okay, this is my virtual big machine that merge every machine specificity. On the other hand, if you want, you can go on really, really detailed description of your activity. So you will provide more precise data about the exact amount of materials that have to be handled, the exact arrival time. You will describe every step of your process and every dependency of your process to adapt to the real solution, to go with a more precise description of what really happened. you can add, you can even explode a machine into its component because you want to track each subcomponent of the machine, of big machine complex. You can add data from, let's say, a weather station. If it's raining, we know that you will not, during this time, handle cereals, for example. So you can choose as you want, or with your constraint as a final user, with the trade-off between precision and simplicity. So that's, we think it's valuable for, again, the small sport context. So now let's have a look with to the outcome module. We've got the path that tell us, okay, considering this bunch of hypotheses, this is what happened. What are the consequences? You will use some module, the outcome module, that are, each one is really dedicated to one little calculus, as simple as possible. Each module will use the path as an input and put it back as an output. A module can add information into the path or cannot, and just, for example, make data transformation. I will filter some kind of category of activity. I will make a zoom, and I will put this data back to the information hubs. And you can also have a preset sequence, ordered sequence of a module. Each module makes a little step in the progress to transform the raw data into information, and if possible, into actionable knowledge. So it seems certainly a little bit theoretical here. So let's jump to some example. I hope it will help to explain why we think it's valuable to start from something really basic, supply chain modeling, to address complex tasks. We'll start with energy. So here we've got the path builder that creates the path. So the path, if you remember, I can cover 1 hour or 1 year of data. Anyway, every activity that's happened, I've got information about. It's related to which ship, which cargo, and I've got information. It starts then, it ends at this time, so I've got duration, and I know which are the machine related during this operation. On the machine specification, you can have energy consumption. I know this machine, this crab, use electricity and this amount for 1 hour. You can go deeper, more detailed, but we keep it simple. So we will be able to add a new information to the path for each activity, the energy that is consumed for each resource. Okay, again, you can sum it, you can do all the calculations that you want, but at the end, you can extract here a time series about your cumulative energy consumption or the sum of every electrical consumption for 1 hour, for example. And this can address complex tasks. For example, if you are a port operator, you really want to avoid your annual energy peak consumption. So if you provide as an input the scenario of your next week boats, at the end you will have a projection of your consumption of electricity. If you see you reach some threshold, your annual peak, you can avoid it. You will delay some shipment, change some things in the process because there is too much cost to reach this annual peak. Something nice is if you imagine a solution, an alternative solution, you can run it as a path model again and see the difference. You can also use external data. If you have photovoltaic panels, you have a time series about your electrical production. So you can run a model on it to forecast next week. So now we've got 2 time series. We can make balance, automatic calculation about the balance between those 2, production and consumption. And now you can alert the grid, electrical grid manager, we need this amount, or we put back into the grid this amount tomorrow. Again, this is something that is pretty interesting for a small sport that starts from nothing. So even if there is uncertainty, you allow to start to get value from the data. Let's jump into environmental consideration. So again, remember, after the pass, you can have unlimited sequence of module. You can even do some loop on it. It's again an oriented graph. So we see that we can have energy consumption. If you know that this machine have consumed this kind of fossil fuel, we can use emission factors to know the amount of pollutants that you have produced. So it can be default emission factors value or specific to your machine. Again, we adapt on what you have as a data. So you know what are the pollutants related to, let's say, this terminal during this week or for this load. You can even make some data transformation on this time series about your production of pollutant, put it back into the information hubs where it is available for other models that will use that as an input to evaluate risk for the city. So I hope you see our point how we try to use simple things to address complex tasks. Now let's talk about perspective. First of all, the work is still in progress. We are still doing some developments. There are some fancy options that are not running as properly as we would like. We also are deploying into 4 ports that are acting as test case, scale 1. And we want that everything runs smoothly. After that, Pixel is an open platform, open code. So we would like that every small port that needs something can use this tool as easily as possible and build a community about how good practice, how to set up this and this, because at the end, a few years after, we are not here. So we need simplicity for community to adopt the tool. Another perspective will be to extend the pass builder scope. Currently, we only manage the C gate, so boats that are load and unload, but we would like to extend it to warehouse stock and interland gates, because again, if you know how to handle, to model how to unload or load a ship, it's not so different to load or unload a truck. There is many same elements here that you can use. Finally, we try to have the module as simple as possible to allow community to add new module to address new tasks. In perfect world, we would like to have some kind of market, module market, like in your Android or any system. Users can add module freely, or we can pay on it. But it's the same idea that the community owns the tool to extend what you can do with it. So thank you for your attention. It was some spotlight on one module of the Pixel platform, the port activity scenario modeling. If you want more information, please visit our website. There's a newsletter. You can follow us on Twitter or email the corresponding people. Thank you very much.